Hello? Okay, okay dengar. Alright. Okay, boleh dengar kan? Can someone confirm you can hear my voice? Okay, alright, thank you. Thank you, Shafiq. Okay, let's start. So, module 10 ni is about automatic scaling and monitoring. So, yang ni memang penting lah, especially kalau dalam sistem. Dalam sistem, first kali kita nak develop satu sistem, application dan sebagainya. Satu, itu yang tim yang expert lah. Tim expert, especially dia ada architect, dia ada architect, and dia ada engineers, expert engineer and so on yang nak build that one. So benda yang dia orang kena kena feature ialah install this automatic scaling and monitoring lah, supaya that infrastructure application ataupun system tu working fine. And also lepas dia develop and deploy, lepas tu ada satu lagi proses orang panggil maintenance lah. Maintenance ni another set of engineer pula yang sebenarnya yang ada sekarang banyak maintenance lah. So kebanyakan sistem dah develop, deploy. So yang maintenance lah. So sebenarnya orang yang baru fresh graduate and so on. So bila dia masuk dalam bidang ni, dia akan duduk dalam bahagian maintenance lah. So kamu akan handle banyak monitoring, alert, scale, automatic scale ini. So benda-benda ni kamu akan nampak lah. So bila kamu dah expert, kamu dah masuk bahagian developer, development. So benda ni juga yang penting lah. Okay, sebelum dan benda ni penting supaya application run smoothly, and then tak ada down and so on. So this module will address the following topics. So first, elastic load balancing, and then Amazon CloudWatch and Amazon EC2. So and then dalam modul ni juga ada aktiviti yang kita tak buat lah, tapi cuma, dan juga ada hands-on lab, hands-on lab untuk Amazon AWS, and then akan ada macam knowledge check and so on. So saya harap kamu semua buat semua modul, buat semua knowledge check and revise or review the question, sebab lepas ni I think next week kita akan ada face to face hari Isnin ni, hari Isnin depan, dan kita akan buat test 2 including all the modules punya knowledge check. So soalannya kebanyakan datang daripada knowledge check lah yang kamu buat. Itu pun sama datang daripada knowledge check and so on, dan ada sebahagian yang lain sikit lah untuk membezakan kamu dengan orang lain. Alright, then next, so after completing this module, you should be able to indicate how to distribute the traffic across Amazon Elastic Compute Cloud, Amazon EC2 instance by using Elastic Load Balancing. And then identify how Amazon CloudWatch enables you to monitor AWS resources and application in real time. Then explain how Amazon EC2 auto-scaling launch and release servers in response to workload changes. And then perform scaling and load balancing tasks to improve an architecture. So section 1, elastic load balancing. So modern high traffic websites must serve hundreds of thousands, if not millions, of concurrent requests from users, from users or clients, and then return the correct text, images, video, or application data in fast and reliable manner. And additional servers are generally required to meet these high volumes. So elastic load balancing is an AWS service AWS service that distribute incoming application or network traffic across multiple targets such as Amazon Elastic Compute Cloud, Amazon EC2 instance, containers, and then also internet protocol addresses and also Lambda functions in a single availability zone or across multiple availability zones. And Elastic load balancing scales your load balancer as traffic to your application changes over time. It can automatically scale to most workloads. Okay. So basically dia ada yang latest two dia buat design baru. So first is an application load balancer. Application load balancer. So kita ada application, kita selalunya dia akan ada load balancer, especially as a HTTP or HTTPS traffic lah. So an application load balancer operates at the application level, open system interconnection or model layer 7. So yang paling atas kali lah, it routes traffic to targets, Amazon Elastic Compute Cloud EC2, instances, containers, internet protocol addresses, and Lambda functions based on the content of the request. It is ideal for advanced load balancing of HTTP and secure HTTPS traffic, and application load balancer provides advanced request routing that is targeted at delivery of modern application architectures, including microservice and container-based application. So an application load balancer simplifies and improves the security of your applications by ensuring that the latest secure socket layer or transport layer security, SSL or TLS, ciphers and protocols are used at all times. So that one is protocol, security protocol dekat layer 7. Kalau kamu masuk dalam bidang ni, memang kamu akan banyak handle banyak security, macam misalnya ada SSL, TLS and so on. And then network load balancer operates, so ada satu lagi kategori type network load balancer. This kita pun nampak ini application yang ni network. So a network load balancer operates at network transport layer, which is layer 4 in OSI model, and then routing connection to targets, EC2 instance, microservices, containers, protocol data. So it works well for load balancing both transmission control protocol TCP and UDP. And a network load balancer is capable of handling millions of requests per second while maintaining ultra low latencies. And network load balancer is optimized to handle sudden and volatile network traffic patterns. So load balancer ni macam ni lah, dia bahagi. So ada wave datang ataupun ni request datang banyak, dia akan bahagikan sama rata ataupun bahagi ikut kita punya define lah. Sebenarnya kita bahagi sama rata, dia akan sebab kita tak nak burden satu server. So sebenarnya kita akan ada satu ke dua biasanya ada 2 server. So kita balancekan 2 server tu. So satu server tu tak down lah. And then this another classic load balancer yang lama previously. So still ada. So a classic load balancer provides basic load balancing across multiple EC2 instance, and it operates at both the application layer and network transport layer. So a classic load balancer supports the load balancing of application that use HTTP, HTTPS, TCP and SSL. So yang ni dia combine sekali. So basically bila kita kata classic load balancer, so dia combine, dia buat 4th layer dengan 7th layer. And the classic load balancer is an older implementation. When possible, AWS recommend that you use a dedicated application load balancer or network load balancer. So yang ni yang lama. So selalunya kalau kita dah tahu bahawa yang kita nak balance kan ialah macam traffic HTTP, and better guna this type of service. Kalau kita tahu yang datang banyaklah network punya request, so banyak kita better guna yang network load balancer lah. So dia lebih fokus dan lebih laju. So a load balancer accept incoming traffic from clients and routes request to its registered targets such as EC2 instance in one or more availability zones. For example, dalam kes ni dia ada request untuk ke dalam kes ni dia letak EC2 lah, EC2 server untuk compute. So bila dia datang, dia akan dalam kes ni dia design untuk dua availability zone. So satu dia load balancer dia letak dekat AZA availability zone A, satu lagi dia letak dekat availability zone B. Okay. So you configure your load balancer to accept incoming traffic by specifying one or more listeners. A listener is a process that checks for connection requests when it is configured with a protocol and port number for connection from clients to load balancer. Similarly, is configured with protocol and port number of connection from the load balancer to the target. So you can also configure your load balancer to perform health check, which are used to monitor the health of the registered targets, so that the load balancer only send request to the healthy instance. So macam ni target dia boleh check server mana yang okey, dia akan hantar lah. Contohnya dalam kes ni server ni problem, so dia akan hantar pada server yang okey. So dia boleh buat health check lah. Basic health check. So termsnya ialah health check. Selalunya dalam server ke apa-apa saja dia kita akan minta buat basic health check. So health check dia okey ke, dia punya ni okey, CPU okey ke apa semua. So dia panggil health check. So when the load balancer detects an unhealthy target, it stops routing traffic to the target. It then resumes routing traffic to that target when it detects the target is healthy again. So dalam kes ni dia target, oh ni unhealthy, EC2 kat sini problem, macam CPU tinggi dan sebagainya. So dia stop and dia akan target pada sini je lah. Kat sini semua healthy, so dia akan load, dia akan bagi sama rata untuk tiga-tiga ni lah. So there is key difference in how the load balancer types are configured. With application load balancer and network load balancer, you register targets in target groups and route traffic to the target groups. With classic load balancers, you register instance with the load balancer. Okay, yang ni ada target groups, kita dah buat siap-siap target groups. Tapi kalau dalam kes ni dia akan kita hanya register instance apalah, contohnya EC2 compute service instance or database dan sebagainya. So kita memang target terus the instance. So there are many reasons to use a load balancer. Yang first kali ialah achieve high availability and better fault tolerance for your application. So elastic load balancer balancing balance traffic across healthy targets in multiple availability zones. If one or more of your targets in a single availability zone are unhealthy, so the elastic load balancing will route traffic to healthy targets in other availability zones And after targets return to healthy state, load balancing will automatically resume traffic to them. And then automatically balance your containerized application. Uh, so with enhanced container support for elastic load balancing, you can now load balance across multiple ports on the same EC2 instance. You can also take advantage of deep integration with Amazon Elastic Container Service, ECS, which provide a fully managed container offering. You only need to register a service with a load balancer, and Amazon ECS transparently manage the registration and the registration of Docker containers. So the load balancer automatically detect the port and dynamically reconfigure itself. Dalam kes dalam container ni kita dah baca tentang, kita belajar pasal container punya teknologi. So kat situ dalam satu EC2 pun dah ada multiple container, multiple macam processing unit. So dia boleh pilih yang mana satu yang healthy and unhealthy. And then it can automatically scale your application. Elastic load balancing works with Amazon CloudWatch and Amazon EC2 auto scaling to help you scale your application to the demands of your customers. So Amazon CloudWatch alarms can trigger auto scaling for your EC2 instance fleet when the latency of any of your EC2 instance it exceeds pre-configured threshold. So Amazon EC2 auto scaling then provisions new instance, and your applications will be ready to serve the next customer request. And the load balancer will register the EC2 instance and direct traffic to as needed. So, and also bila ada elastic load balancer, dia boleh check healthy ke unhealthy. And then dia boleh check might be threshold dah tinggi, and dia boleh hantar event. So bila threshold dah tinggi, dia boleh update supaya tambah lagi CPU ataupun tambah lagi RAM, tambah dan sebagainya. Okay. And then use elastic load balancing in your virtual private cloud. So you can use elastic load balancing to create a public entry point into your VPC, or to route request traffic between tiers of your application within your VPC. You can assign security groups to your load balancer to control which ports are open to a list of allowed sources. So because elastic load balancing works with your VPC, all your existing network access control list as ACL and routing tables continue to provide additional network controls. So when you create a load balancer in your VPC, you can specify whether the load balancer is public default or internal. So if you select internal, you do not need to have an internet gateway to reach the load balancer, and the private IP address of the load balancer will be used in the load balancer domain name system DNS record. So nanti kita tengok pasal VPC, and then is enable hybrid load balancing. So elastic load balancing enables you to load balance across AWS and on-premise resources by using the same load balancer. So kita boleh guna load balancer untuk direct the traffic between cloud dengan on-premise and on-premise. Kita boleh guna macam tu juga. And And then, for example, if you must distribute application traffic across both AWS and on-premises resources, you can register all the resources to the same target group and associate the target group with a load balancer. Alternatively, you can use DNS-based weighted load balancing across AWS and on-premise resources by using two load balancers, with one load balancer for AWS and other load balancer for on-premise resources. You can also use hybrid load balancing to benefit spread application, where one application is in a VPC and the other application is in an on-premise location. So put the VPC targets in one target group and the on-premise targets in another target group. So, and then use content-based routing to route traffic to each target group. That one for hybrid environment. And then the last one, invoking Lambda function over HTTPS. Elastic load balancing supports invoking Lambda functions to serve HTTPS requests. So this enable users to access serverless application from any HTTP client, including web browsers. So you can register Lambda functions as target and use the support for content-based routing rules in application load balancers to route request to different Lambda function. Lambda function ni yang kita belajar sebelum ni ialah dia coding instruction untuk infrastructure lah. So dia macam tu lah, kita biasa buat coding, if jadi yang ni buat ini, jadi ini buat ini. So Lambda is a part of Lambda service, Lambda function service. And you can use an application load balancer as a common HTTP endpoint for applications that use servers and serverless computing. So you can build an entire website by using Lambda functions or combine EC2 instance containers on-premise servers and Lambda function to build application. So either kita guna Lambda function ni, Lambda function ni kita tak manage. Kita tak manage the servers. Semua basically AWS yang handle. Or kita bina sendiri the servers, the instance, container apa semua, kita combine sekali dengan Lambda function. So ini activity. Do later. Okay, you can use the following features to monitor your load balancers, analyze traffic patterns, and troubleshoot issues with your load balancers and targets. So, so dia ada tiga function, which is satu Amazon CloudWatch matrix. So elastic load balancing publish data point to Amazon CloudWatch. Amazon CloudWatch adalah sebahagian dari service yang di-offer oleh Amazon. Dia monitoring service. So Amazon CloudWatch for your load balancers and your target. So CloudWatch enables you to retrieve statistics about those data points as an ordered set of time series data known as metrics. You can use metrics to verify that your system is performing as expected. For example, you can create a CloudWatch alarm to monitor a specific metric and initiate an action such as sending notification to an email address if the metric goes outside what you consider an acceptable range. So kita boleh buat action lah kalau dia macam contohnya dia macam melebihi threshold yang kita tetapkan. Apa yang dibuat, dia akan hantar alert ke, dia akan hantar ke email dan sebagainya. So dia akan hantar kepada admin punya email lah. So itu yang berlaku dalam enterprise kan. So bila anything happen, kita akan dapat alert dan admin akan response to the alert. Itu yang apa ni? Engineer yang first level yang akan buat lah, dia akan tengok alert apa yang keluar, apa yang problem dan sebagainya, CPU tinggi ke, anything lah. So database ke apa semua, so dia akan alert pada level 2 and level 3. Engineer level 2 and level 3 engineer akan, so dia kata okay, iaitu false alert ke real alert ke problem ke, dia akan hantar. Kalau false alert, dia akan just delete the email. So access logs, so you can use access logs to capture detailed information about the requests that were made to your load balancer and store them as a log files in Amazon Simple Storage Service. You can use these access logs to analyze traffic patterns and go to troubleshoot issues with your targets or back-end application. So this is very, very important as a cloud administrator. Sebab macam saya kata lah, macam yang CTO Amazon kata, everything fails. Everything fail. Tapi macam mana nak troubleshoot? Troubleshoot tu kita mesti ada log. Kita nak tengok waktu tu kenapa dia down, apa yang jadi, apa yang telah terjadi kan, ada orang masuk ke CPU tinggi ke semua. So we need this access log to troubleshoot. So very, very important. And then AWS CloudTrail logs. Yang ni lebih detail. So you can use AWS CloudTrail to capture detailed information about the calls that were made to the Elastic Load Balancing Application Programming Interface API and store them as log files in Amazon S3. So you can use this CloudTrail logs to determine who made the call, what calls were made, and when the calls was made, the source IP address of where the call come from and so on. Yang ni for detail kan. Ini istilahnya macam untuk dia panggil root cause analysis lah. Yang ni kita penting bila kita nak ada benda service down dan sebagainya, kita nak cepat nak troubleshoot, nak upkan balik service. Yang ni untuk kita lepas pada benda tu, kita nak check betul details. Sebenarnya kita nak check details siapa yang buat dan sebagainya. Jadi lebih detail lah. Yang ni macam audit dan sebagainya lah. Right. So some key takeaway: Elastic load balancing distribute incoming application or network traffic across multiple targets in more available zones. So pentingnya ni untuk make sure tak ada service yang down or slow. Okay, so they distribute the request semua tu pada multiple server. And then Elastic load balancing supports 3 types of load balancers: application load balancers, network load balancers, and classic load balancer. So classic ni is combination of these two. Sebab yang currently kita ada 2 ni, so dia memang recommend untuk guna 2 ni. Tapi kalau kita tak tahu dan sebagainya, tu classic load balancer ni boleh buat layer 4 and layer 7 punya distribution. So an Elastic load balancer offers an instance health check. Ni yang penting, health check, security, and also monitoring. So section 2 is about Amazon CloudWatch. Tadi kita ada sebut pasal CloudWatch. So kali section 2 ni kita akan masuk dalam this service. It's important for the maintenance side. So to use AWS efficiently, you need insight into your AWS resources. For example, you might want to know when you should launch more Amazon EC2 instance. If your application performance and availability is being affected by lack of sufficient capacity, capacity kurang dan sebagainya. So kita nak tahu bila, takkan kita nak tengok, kita masuk kerja, kita nak tengok dekat monitor kan. Kita nak komputer yang buat kerja and alert kita. Alert kita, dan mungkin kita kalau benda tu dah selalu, kita boleh buat automate. Kalau benda ni keluar, so you buat apa, tambah resource dan sebagainya. So how much your infrastructure is actually being used. So kita boleh monitor juga berapa banyak yang dah digunakan. So untuk misalnya untuk cost dan sebagainya lah. And how do you capture this information? So you can capture this information with Amazon CloudWatch. So Amazon CloudWatch is a monitoring and observability service that is built for DevOps engineer, developer, site reliability engineers, and IT managers that like you guys nanti lah kalau you masuk dalam bidang ni lah. And then CloudWatch monitor your AWS resources and the application that you run on AWS in real time. So you can use CloudWatch to collect and track metrics, which are variables that you can measure for your resources and application. And then you can create an alarm to monitor any Amazon CloudWatch metric in your account and use the alarm to automatically send notification to an Amazon simple notification service or Amazon SNS topic or perform an Amazon EC2 auto scaling or Amazon EC2 action. So tadi kalau kita dah dapat macam apa ni, kalau kita dapat something lah, for example, you can create alarms on the CPU utilization of an EC2 instance. So elastic load balancing requires a latency Amazon DB table throughput. Ni macam kalau dalam database dia tengok pula throughput kan. Elastic load balancing kita tengok latency. Latency dia macam mana, slow ke? Kalau slow maksudnya ya tak bergerak lah, tak function or something wrong. So Amazon DB kalau throughput the problem or Amazon simple queue service, SQL length or even the charges on your AWS bill. So bill pun kita boleh monitor juga kalau dia dah lebih kan. And you can also create an alarm on custom metrics that are specific to your custom application or infrastructure. So ada benda-benda yang kita nak monitor, kita boleh guna Amazon CloudWatch untuk dapatkan an alarm kita. And then you can also use Amazon CloudWatch events to define rules that match incoming event or changes in your AWS environment. Route them to targets for processing. And then targets can include Amazon EC2 instance, AWS Lambda functions, Kinesis streams, yang ni service yang adalah yang ni untuk live streaming and so on, live data streaming, Amazon ECS stars, container, state function, state machine yang ni untuk AI, Amazon SNS topics, yang ni untuk macam alert tadi, dia macam and then Amazon SQS, queues and built-in targets. So CloudWatch event. So Amazon CloudWatch event becomes aware of operational changes as they occur. And then CloudWatch events responds to these operational changes and take corrective action as necessary by sending messages to respond to the environment, activating functions, making changes and capturing state information. So event ni bila anything happen, kita kalau kita automate, kita dah buat okay, kalau benda ni jadi buat macam ni sebagainya lah. So with CloudWatch, you gain system-wide visibility into resource utilization, application performance, and operational health. So there is no upfront commitment or minimum fee. You simply pay for what you use, and you are charged at the end of the month for what you use. So kita nak guna free, tapi bila dia dah start utilize, so kita kena bayar. So you can create a CloudWatch alarm that watch a single CloudWatch metric or the result of math expression based on CloudWatch metric. You can create a CloudWatch alarm based on static threshold, anomaly detection, or a metric mask expression. So when you create an alarm based on a static threshold, you can choose a CloudWatch metric for the alarm to watch and threshold for the metric. And the alarm goes to alarm state when the metric breach the threshold for a specific number of evaluation periods. So for an alarm based on a static threshold, you must specify the namespace. So a namespace contains the CloudWatch metric that you want. For example, AWS EC2. A metric is the variable that you want to measure. For example, a CPU utilization. And then statistic that can be average, sum, minimum or maximum, or sample count, or a defined percentile, or a custom percentile. And then also period. Period is the evaluation period for the alarm. For when the alarm is evaluated, each period is aggregated into one data point. So condition, when you specify the condition for a static threshold, you specify whenever the metric is greater or equal, lower or equal or lower than the threshold value, you also specify the threshold value. And then additional configuration, this includes the number of data points within the evaluation period that must be breached to trigger the alarm, and how CloudWatch should treat missing data when it evaluates the alarm. And then actions, you can choose to send a notification to an Amazon SNS topic. Yang ni macam kita panggil apa, macam SMS lah, macam SMS yang tu belakang lah. Or to perform an Amazon EC2 auto scaling action, nak tambah resource ke apa, so auto scale, then semakin naik atau semakin turun, or Amazon EC2 action. And then for this activity, tengok ni macam if average CPU utilization is 60%, over 60% for 5 minutes, if the number of simultaneous connection is 10 for 1 minute. So banyaklah proses. Contohnya dalam EC2, dalam ADS, dalam AS3, dalam elastic load balancing, dalam Amazon Elastic, kita letak threshold, or kita letak berapa value yang kita rasakan threshold. So some key takeaways from this session is Amazon CloudWatch help you to monitor your AWS resources and the application that you run on AWS in real time. So basically, they enable you to collect, track standard, custom metrics, set alarm, and define rules that match changes in your AWS environment, and route this event to target for processing. So tadi kita dah tengok pasal CloudWatch, so sekarang kita tengok Amazon EC2 auto scaling. So when you run your application on AWS, you want to ensure that your architecture can scale to handle changes in demand. So in this section, you will learn how to automatically scale your EC2 instance with Amazon EC2 auto scaling. So scaling is the ability to increase or decrease capacity of your application. To understand why scaling is important, consider this example of workload that has been varying resource requirements. So in this example, the most resource capacity is required on Wednesday. On Wednesday kat sini kan, on Wednesday. So hari biasa, hari Ahad kurang, hari Monday 50%, Thursday 60%, Wednesday adalah 100% lah. And the least resource capacity is required on Sunday lah. So one option is to allocate more than enough capacity so you can always meet your highest demand, in this case Wednesday. So however, this situation means that you are running resources that will be underutilized most day of the week. So kat sini kalau kita nak bagi semua dapat, kita bagi semua tinggi lah, sama level yang paling tinggi sekali. Tapi untuk hari ini okey lah. Tapi hari lain tak ada unused capacity, rugi. Ini semua kita kena bayar ni. So however, this situation means that you are running resources that will be underutilized most days of the week. With this option, your costs are not optimized. Another option is to allocate less capacity to reduce cost. Satu lagi kita nak reduce cost, kita bagi sikit lah banding yang ni. Tapi untuk hari Wednesday ni kita akan ada problem lah. So your application will could underperform or potentially even become unavailable for users. Kadang-kadang terus down sebab under provision overuse. So in the cloud, because computing power is a programmatic resource, you can take a flexible approach to scaling. So Amazon EC2 auto scaling is an AWS service that helps you maintain application availability, enables you to automatically add or remove EC2 instance according to condition you define. So you can use the fleet management features of EC2 auto scaling to maintain the health and ability of your fleet. So dalam kes ni tengok macam dia akan ikut capacity pada setiap hari lah, berapa yang dia perlukan. So dia akan dia kalau dia target lebih pada ni, dia akan tambah lagi. So dia tak akan kurang, dia tak akan lebih. So Amazon EC2 auto scaling provides several ways to adjust scaling to best meet the needs of your application. You can add or remove EC2 instance manually on the schedule in response to changing demand. So or in combination with AWS auto scaling for predictive scaling. And then dynamic scaling and predictive scaling can be used together to scale faster. Dia ada macam-macam lah untuk buat benda tu, to make sure is not overutilized and not underutilized. So automatic scaling is useful for predictable workloads. For example, the weekly traffic at the retail company Amazon.com. So automatic scaling is also useful for dynamic on demand scaling. Amazon.com experienced a seasonal peak in traffic in November. On Black Friday or dekat Amazon traffic atau kat US, dia ada macam New Year punya shopping lah, waktu tu tinggi lah. So dia panggil Black Friday and Cyber Monday, which are days at the end of November, when US retailers hold major sales. So if Amazon provisions a fixed capacity to accommodate the highest use, 76% of the resources are idle for most of the year. So capacity scaling is necessary to support the fluctuating demands for the service. So without scaling, the service could crash due to saturation, and the business would also lose customers. So dalam kes ni, daripada awal bulan sampai sampai dekat bulan November, December dia tinggi lah. Tapi yang lain selain pada tu, it is unused. Okay. So therefore, an auto scaling group is a collection of Amazon EC2 instances that are treated as a logical grouping. for the purpose of automatic scaling and management. So the size of an auto-scaling groups depend on the number of instances is set as the desired capacity. So you can adjust its size to meet demand either manually or by using automatic scaling. You can specify the minimum number of instances in each auto-scaling group, and Amazon EC2 auto-scaling is designed to prevent your group from going below the size, and you can specify the maximum numbers of instances in each auto-scaling group. And Amazon EC2 auto-scaling is designed to prevent your group from going above this size. So for example, kalau kita ada macam kita kata minimum pun ada 2 EC2. So bila dia threshold dia rendah, dia akan sampai dia akan operate 2 EC2 je. And then maksimum kita kata kalau maksimum kalau banyak traffic pun kita hanya boleh bekalkan dalam kita boleh guna 4 EC2 saja instance. So kalau traffic tinggi dia akan guna 4 instance je lah. So kalau dia maksudnya dia bergerak pada 2, 3, 4 saja. So dia tak lebih. Kalau lebih takut kita kena bayar lebih lah kan. Itu tak boleh. So if you specify desired capacity either when you create the group or at any time afterwards, Amazon EC2 auto-scaling is designed to adjust the size of your group. So for example, this auto-scaling group has a minimum size of 1 instance, minimum size 1 instance, and maximum size of 4 instance. And the scaling policies that you define adjust the number of instances with your minimum and maximum number of instances based on the criteria that you specify. So with Amazon EC2 auto scaling service, launching instance is referred to scaling out. Bila kita nak tambahkan EC2, kita the term is dia panggil scaling out. Terminating instance is refer to scaling in. Scaling in tu macam mengecut, kalau saya scaling out tu macam berkembang lah. Kembang tu dia tambah instance lah. Okay. So to launch EC2 instance and auto scaling groups use a launch configuration which is an instance configuration template. You can think of a launch configuration as what you are scaling. So when you create a launch configuration, you specify information for the instance. So the information you specify includes the ID of the Amazon machine image, AMI, the instance type, IAM roles, security groups, and EBS volumes. And you define the minimum and maximum number of instances of your auto scaling group. Then you launch it into a subnet within the VPC. You can think of it as where you are scaling. And then Amazon EC2 auto scaling integrates with elastic load balancing to enable you to attach one or more load balancers to an existing auto scaling group. So after you attach the load balancer, it automatically registered the instance in the group and distribute incoming traffic across the instance. So VPC, private subnet, and auto scaling group dalam ni. And then finally you specify when you want the scaling event to occur. You have many scaling options. First, maintain current instance levels at all times. Or menu scaling. With menu scaling, you specify only the change in the maximum, minimum, or desired capacity of your auto scaling. Or schedule scaling. With schedule scaling, scaling action are performed automatically as a function of date and time. So this is useful for predictable workloads when you know exactly when to increase or decrease the number of instances in your group. Or another is dynamic or on-demand scaling. Yang ni yang automatic lah. So a more advanced way to scale your resources. Enables you to define parameters that control the scaling process. And for example, you have a web application that currently runs on 2 instances and you want the CPU utilization of the autoscaling group to stay close to 50%. So when the load on the application change, this option is useful for scaling in response to changing conditions. So when you don't know when those conditions will change, dynamic scaling gives you an extra capacity to handle traffic spikes without maintaining an excessive amount of idle resources. So you can configure your auto scaling group to scale automatically to meet this need. So macam tu lah, kalau kita nak CPU dalam 50%, bukan dalam 50%, dekat dengan 50%, maksudnya kalau dia dekat dengan 50%, okay, maintain. Kalau lebih pada 50%, dia akan tambah. Kalau kurang pada 50%, dia akan eliminate and so on. And also we have predictive scaling. You can use Amazon EC2 auto scaling with Amazon auto scaling to implement predictive scaling, where your capacity scales based on the predicted demand. So predictive scaling use data that is collected from your actual EC2 usage, and the data is further informed by billions of data points that are drawn from our own observation. So kita boleh guna data yang dia dah collect pada kita punya EC2 untuk buat predictive scaling, and juga based on dia punya information. So one common configuration for implementing dynamic scaling is to create CloudWatch alarm that is based on performance information from your EC2 instance or load balancer. So when a performance threshold is breached, a CloudWatch alarm triggers an automatic scaling event that either scales out or scales in EC2 instance in the auto scaling group. So contohnya ada Amazon EC2 ni, dia detect if average CPU utilization is above 60% for 5 minutes. So dia detect dalam CPU, so dia akan bagi data tu kepada EC2 auto scaling. So auto scaling akan tambah lagi that instance. So to understand how it works, consider this example. You create an Amazon CloudWatch alarm to monitor CPU utilization across your fleet of EC2 instance and run automatic scaling policies if the average CPU utilization across the fleet goes above 60% for 5 minutes. So yang penting lah sebenarnya CPU ni dia fluctuate. Kadang dia 100%, sekali dia 50%, sekali dia 70%, sekali dia 30%, dia fluctuate. So sebenarnya yang problem ni ialah bila dia macam dia constant, contohnya 100% constant sampai 5 minit. Itu yang penting. Kita bukan nak target 100% CPU 100% sebab kadang-kadang dia spike sampai 100% tapi dalam 1 saat je. Dan dia dah turun balik. Dia ada proses lah kan. Tapi kalau dia spike 100%, dia tak turun sampai 5 minit, itu problem. So sebenarnya kita letak utilization dia sekali dengan masa lah. So Amazon EC2 auto scaling instantiate a new EC2 instance into your auto scaling group based on the launch configuration that you create. So after new instance is added, Amazon EC2 auto scaling makes a call to elastic load balancing to register the new EC2 instance in that auto scaling group. And then elastic load balancing then perform the required health checks and start distributing traffic to that instance. So elastic load balancing route traffic between EC2 instance and feeds metrics to Amazon CloudWatch. So bila dia dapat data pada Amazon CloudWatch, so auto scaling akan create another instance and then dia akan hantar data kepada elastic load balancer, kata dia dah tambah another instance. So load balancer akan check, health check, and dia akan route the traffic into the new one. And then Amazon CloudWatch, Amazon EC2 untuk scaling and elastic load balancing work well individually. Together, however, they become more powerful, increase the control and flexibility over how your application handles customer demand. So far you learn about scaling EC2 instance with Amazon EC2 auto scaling. You also learn that you can use Amazon EC2 auto scaling with AWS auto scaling to perform predictive scaling. So AWS sekarang ni dia ada satu pula service yang dipanggil AWS auto scaling. AWS auto scaling is separate service that monitors your application. It automatically adjusts capacity to maintain steady predictable performance at lowest possible cost. The service provides a simple, powerful user interface that enables you to build scaling plans for your resources, including Amazon EC2 instance and spot fleets, and then Amazon Elastic Container Service, plus Amazon DynamoDB tables and indexes, and Amazon Aurora replicas. Any duplicate any database. So if you are already using Amazon EC2 auto scaling to dynamically scale your EC2 instance, you can now use it with AWS auto scaling to scale additional resource for other AWS service. Right, that one for section 3 takeaway. So dalam ni ada lab 6, so please do that. So dalam lab ni kita tengok you will use elastic load balancing and Amazon EC2 auto scaling to load balance and scale your infrastructure. So you start with the given infrastructure. So in this lab you will complete following tasks: create an Amazon machine MI. So dalam ni ada dalam VPC dan AZ2, security 2. So we create Amazon machine image and then application load balancer. They create launch configuration and auto scaling groups. And they automatically scale new instance within a private subnet, and they create Amazon CloudWatch alarms and monitor performance of your infrastructure. So perfect. So please do that, and the diagram summarize what you will have built after you complete the lab. Application load balancer, auto scaling group, dalam security group, web instance, and RDB. Okay, that's all for the last module. So in summary, in this module, you learn how to indicate how to distribute traffic across Amazon Elastic EC2 instance, using elastic load balancing, and identify how Amazon CloudWatch enables you to monitor AWS resources and application in real time. And then explain how Amazon EC2 auto scaling launch release servers in response to work changes, and perform scaling and load balancer to improve the application. So please complete the knowledge check. So banyak soalan-soalan ni datang dari sini. Which service would you use to send us on Amazon CloudWatch? So for example, Amazon Simple notification service. Kalau tak faham boleh Google ataupun tanya saya pun boleh. Tapi lagi cepat tanya Google. But semua ni is already well known. Okay, thank you. Ada soalan tak? Thank you very much. So saya ingatkan balik hari Senin depan kita ada kelas face to face and 1 jam kita akan buat test 2. So test 2 soalan dia sejam. So basically untuk semua modul lah, daripada modul 1 sampai modul 10. Basically banyak soalan dah ada dalam knowledge check and also so please complete all the modules. So make sure you complete all items supaya nanti dapat claim badge. You can put in your resume and so on. So please complete it. Nanti update pada saya akan akan tengok. Please complete and please do the knowledge check untuk test minggu depan. Alright. And minggu depan kita akan masuk Google Cloud. Kita akan tak sure sempat habis tak, tapi kita akan pilih yang penting. Tapi kebanyakan benda yang untuk cloud infrastructure and service tu kita dah address dalam Amazon AWS ni lah. Alright, and then jangan lupa buat lab and hantar report pada Google Drive. Alright, that's all. Thank you everyone. Thank you for your time. That's all. Have a good rest. Thank you.
Thank you, sir.
Thank you.